morning, everyone. Myself, Sharmila, working as assistant professor in R.M.D. Engineering College. In today's session, we're going to discuss about principles of source optimization. In the last session, what we have discussed is about how to optimize a code, how to draw a DAG structure for the given source code program. I hope you understand with the example. In today's session, we're going to discuss about principles of source optimization. In the principles of source optimization, a transformation of program, the local performed by looking only at the statement, the basic block is called as global. Many transformation can perform both local and global. Local transformation is usually performed first. In that function preservation transformation, there are common sub-expression elimination, copy propagation, deadline elimination, constant folding. These are the function preservation. What we are going to do is we're going to optimize the code using that techniques. Common sub-expression elimination means, for example, here 4 into I, 4 into I, this both the expression is common. So instead of that, you can write T3 and T1 in the same, and you can write T3 equal to T1 or T1 equal to 3. One expression is enough. That is a common sub-expression elimination. Copy propagation is nothing but we are copying the value again and again. Pi value is x, again you are writing. Instead of that, you can write A equal to Pi into R into R. Directly you can assigning the x value. Instead of that, you can eliminate that line. Directly you can write A equal to Pi into R into R. Next one is dead code elimination. If you see here, we are not even going to inside the loop because I equal to 0 always. The I1 we are not going. So this code itself is a dead code, so we can eliminate it. Constant folding is nothing but, for example, 3.14 divided by 2. The value you know already, it's 1.570. Instead of doing a division, wasting of a cost of the memory, you can directly write A equal to 1.507. Instead of writing 2 plus 3, you can directly write 5. So that is a constant folding. Loop optimization is nothing but we have a two types in that again technique. Code motion, induction. The code motion is nothing but which moves the code outside a loop. Induction is a variable elimination which we apply to replace a variable from the inner loop. Reduction is a strength in which replace an expensive operation by cheaper one, such as a multiplication of an addition. Instead of multiplication, we can do addition. Code motion is the nothing but is a code is a loop of code motion. Is trans expression yield the same result. Loop invariant computation and places the expression before the loop. So they have given example here. Statement does not change the limit. Instead of writing this, you can write the statement like this because it's a code motion. Next one is induction variable. Induction variable is nothing but the loop as usually process inside and out. Here the I values keep on changing. We can directly write here that is the induction variable. Next one is reduction in strength is the nothing but the replace the expensive operation. We can go for cheaper one, and the cheaper one in the sense instead of using multiplication or instead of using a power, we can directly use a plus and we can do it. That's an example. X square, instead of that you can use x into x exponential routine. The power to power cheaper, they are saying. Then that floating point division by constant can be implemented as a multiplication by a constant which may be cheaper. So what they are trying to say is we can use, instead of doing multiplication, you go for addition. The cheaper cost they are expecting is, for that reason we are going for the rent strength, reduction strength. So here what we have discussed is principle of source optimization. So there are the 5 different technique: function preserving transformation, in that common sub expression elimination, copy propagation, deadlock elimination, dead code elimination, constant folding. Again in that we have seen for common sub expression how to eliminate a sub expression, copy propagation how to copy the value, instead of that directly you can write, and deadlock code elimination, this code is not useful, instead of you writing that you can eliminate it. And constant folding nothing but directly you know the value 2 plus 3 is 5, directly you can write 5. Instead of writing 2 plus 3 you are adding addition operator, directly you can write the constant value, that is called the constant folding. Loop optimization, again we have code motion, induction and reduction in strength. In the code motion wow, you can write the limit value t equal to limit minus 2, we have seen one example. And induction variable loop are usually proposed inside and out. How to write that, we have seen induction variable. Reduction in the strength, that is nothing but we are using multiplication, keep on, instead of that write plus, for that x square x into x, like that they are saying. Instead of using power exponential, write the multiplication, it is cheaper. Okay, This is a code optimization principle of code optimization. We have discussed in the last fifth unit how to optimize a code. The final stage of compiler is the code generation. After generating a code, what we are trying to say is how to optimize the code. That is the main key idea about the fifth unit. In the unit 1 we have discussed about what are the different Thomson construction method, how to draw a DFA, NFA, minimized NFA, minimized DFA. In unit 2 we have discussed about three address code writing and solving the problem like SFR, NFR, LLR1, LR0, like that. In the unit 3 we have discussed about intermediate code generation. Unit 4 how to optimize it, how to reduce it. In the final unit 5 we have discussed about how to reduce the code, how to use the optimization technique. So there are the 7 phases of compiler. We have discussed what are the different phases and how to reduce it into a finally target vision code. The main motto of the compiler design is what is the back end of the compiler system, how it is working from source program to the target program, how the program is keep on executing the values. That is a different phase of compiler we have discussed. I hope you understand all the videos. Thank you for listening. With the example I have explained, if you want, go to the previous video and see how to reduce, how to draw a tag, how to write a basic block for the given using the algorithm. Thanks for listening. Thank you.